This lesson is for week 2, lesson 4. This one's on slant asymptotes. Here's our handy dandy chart that you've seen multiple times at this point. And we're going to be taking a look at slant asymptotes. So we're looking where specifically the degree of the numerator is exactly 1 greater than that of the denominator. Okay, and it has to be that specific. It's not just greater in general, it has to be exactly 1 greater. And you find it by doing long division. And you will, I'm going to show you some examples. You will ignore the remainder. So let me move this up here. We're going to do this one first. That looks good right about there. Okay, so if you look at this one, the numerator is factorable. All right, it is x minus 1 times x minus 1. But because it doesn't cancel with anything, there's no chance of a whole. Right, so you always check for wholes first, because nothing cancels, and we do see that the degree of the numerator is exactly 1 more than the degree of this denominator. It has a slant. We are guaranteed that there is a slant asymptote, and we're going to find it by doing long division. So we're going to divide the numerator by the denominator. All right, so I need this x to go into this x squared, which is going to go x times. Then you multiply, and you subtract, and you bring down. Now I need x to go into negative 2x. I can multiply by negative 2, which gives me negative 2x. When I subtract and bring down, I have a remainder of 1, but if you look up in the top, it says to ignore the remainder. So this slant asymptote is exactly what you see up here. It is y equals x minus 2. All right, so let's take a look at this one. Now, at first glance, you might think it has a slant asymptote, right? The degree of the top is 2. The degree of the bottom is a 1. It looks like it has a slant. But don't forget, you have to factor first. If I factor this thing first and I see, oh wait, there's a common factor, this actually has a hole, right? It doesn't have a slant asymptote. So please don't fall into that trap. All right, teachers are famous for setting that trap. So here, let's take a look at our last example. Okay, now again, similarly, the numerator here does factor, all right? And you can check that out for yourself. It does factor. But it's not going to cancel with anything. So what we're going to do instead is we're going to do long division. So I need x minus 1, that's the denominator, to divide into x squared plus x minus 6. So hopefully you remember long division. I need x to go into x squared, which is going to go x times. Then I'm going to multiply and get x squared minus x. When I subtract, this becomes 0. This, when you subtract a negative, is the same thing as adding. All right, and you bring down. So then, let me erase some of these marks. So then I need this x to go into this 2x, which goes 2 times. And then I multiply, sorry, that's a positive, minus 2. And then when I subtract, this becomes 0. When you subtract a negative, it's the same as adding, so this becomes negative 4, but the remainder doesn't even matter. We are just looking for the quotient. So this slant asymptote is y equals x plus 2.